Today I wanted to go over a quick introduction to what it means to be an inverse function. So our essential question we're asking here is, how do you find the inverse of a function, and how is the original function related to that inverse? We'll have to address that over several topics, but hopefully these brief examples can give us an introduction to what we need. So one of the simplest ways to diagram a relationship or a function is by using a mapping. So this list over here is my inputs, and the corresponding outputs are here. So without even giving an equation or a function rule, we can see that 1 as an input results in an output of 2, 3 as an input results in an output of 4, 5 as an input results in an output of 6. The inverse of that function would take the original function and undo everything that was just done. So when we can do that, we're meeting the conditions for an inverse function. So this time our input is 2 and the output is 1. Input is 4, output is 3, input is 6, and output is 5. We are undoing or going in the reverse of what we started with. Okay, and when we can justify that that's happening, we can say our two functions are considered inverses of each other. Okay, we also have this fancy notation for when we know the equation we're looking at is the inverse of another. And they use this f with a little -1. It's not an exponent, but it looks like a superscript like that. So you do f with a little -1, where an exponent would typically be, and then parentheses x. So this is your symbol for an inverse. I don't really love it, and a lot of other mathematicians don't love it either, but this is pretty standard for most textbooks. So let's take a look at this example as a graph. And I've already plotted our original function. Let's take a look at how our inverse looks in relation to the original. Okay? So I've got the original 3 points, 1, 2, 3, 4, and 5, 6. If I take a second and plot the inverses of those, again, I'm flipping the x's and the y's. So the first point would be 2, 1. The next point would be 4, 1, 2, 3, 4, up 3. And then the next point would be 6, 5. So 1, 2, 3, 4, 5, 6. And then up 1, 2, 3, 4, 5. Okay? So the original here is in a pinkish purple, and then the inverse is here in blue. How are those two graphs related? You can see there's some type of symmetry, but it's not what we would typically think. For inverse functions, the symmetry that occurs is actually across this diagonal line, and from your parent functions you should recognize what this diagonal line is. If I can draw it accurately here. Okay, it's a little bit off, but this diagonal line is the line y equals x, or if you think about it in functions, f of x equals x. So that is the parent function for a linear function. And anytime you have two relationships that are considered inverse functions of each other, this kind of a relationship will always occur. Okay, let me go through another example with you so hopefully you can get an understanding. Example 2 here, I have these points plotted in green already. So that would be the points -2, 4, 3, 5, and -3, -4. The inverse of those, again, we are going to use this fancy notation, so that your f with a little -1 of x. And all I'm going to do is take each of these x and y values and flip them. And when we plot these points, if everything goes to plan, they should have a symmetry across the point, the line y equals x. And I'm going to use the pink here to indicate that. So 4, -2 is my first point. So 1, 2, 3, 4, down 2. 5, 3 is my second point. 1, 2, 3, 4, 5, up 1, 2, 3. And then -4, -3. Okay, so it's maybe a little bit hard to tell just by looking at it that way. So again, if we draw y equals x, we should see a mirror image across those lines. And it looks like, just a quick rough estimate by putting the ruler here, that that is true. Okay, so that helps us verify, again, if I can draw a little bit more accurately, but that we have an inverse function because we can draw on that line y equals x, and the left hand side is a mirror image of the right hand side of that line. Okay, so we have inverse functions, and we can look at things that way, whether it's a point or a graph. And just to quickly, a third example, if we have a function that we know, let's say we have a square root function. So f of x equals the square root of x. And we're asked about that. What you can do is you can pick some of the basic points that go along with that on a typical table that you know. So from some of our earlier videos, let's say we had 0, 0, and then another point we know is 1, 1, then 4, 2, and then another point we know that works out well, the square root is 9, 3. Okay, the inverse of those, so f of negative 1 of x. Okay, a lot of people would have trouble with the equation initially, but you could easily come up with a table and how that would look for your new function. So your first 2 points would actually be the same, 0, 0, 1, 1, but then you would have the point 2, 4, and then 3, 9. Okay, so let's take a quick second and see what those graphs would look like. I'll just do that real quick without the ruler, so I don't take too much of your time. And we know it's a little bit challenging to plot some of these points when you have a large number like 9. So I've got 0, 0. I'll do that in pink. 1, 1, 4, 2. So 1, 2, 3, 4 up at 2. And then 9, 1. So this would be 6, 8, 9, 2, 9, 3. I'm sorry. So that is the beginning of our square root function. It will look something like that. And then when we go to graph our inverse, I'll do that in a light blue here. You have the same first 2 points. I'll circle them so that it doesn't get messy. So 0, 0, 1, 1, but then we've got 2, 4, and then we have 3, 9. That would be way up here. So 3, 6, 9. Your graph would look like that. Okay, and we can see if I continued drawing this going upwards, it does appear that we have that same kind of inverse relationship where you can draw your diagonal at y equals x, and the graphs match up nicely. Okay, so the inverses of each other again graphically fit that characteristic, and then in terms of a table or mapping, you're just simply flipping your x's and y values. Okay, so hopefully this is a good introduction. We'll explore this a lot more in terms of algebra and other properties as we go forward. Thanks for watching.